Chapter 1. The Where, Why, and How of Data Collection. We continue on with Learning Outcomes 2 and 3, and we'll discuss the difference between a population and a sample, and how to understand the similarities and differences between different sampling methods. A population is a set of all objects or individuals of interest, or the measurements obtained from all objects or individuals of interest. So, for example, one population of interest might be college students. When we take a sample, we are going to study a subset of the population. If we take a census, we are going to study the entire population. Let's look at an example. Here we have our population of interest is MiraCosta College students in 2017, which totaled 14,773 students. To understand how much sleep these students get nightly, we could take a census of all 14,773 students, or we could take a sample of 300 students. Now, in organizations, a sample is more efficient and cost-effective than to study the entire population through a census. So those are the kinds of decisions that we want to make when trying to understand what's going on in a population. Now, when we think about population, it's easy to remember parameters, P for population. A parameter is some numerical measure, like an average or a proportion, that is computed from the population. So the example here would be the average time it takes for all MiraCosta College students to find parking on campus on Mondays. Another example might be the proportion of all university students in California who have more than $40,000 in student loans. So think parameters is information about the population. Now we have statistics, which is S for sample. When we talk about samples, we can also calculate statistics, just like in this class, in terms of, again, averages or proportions, but now they're computed specifically from a sample selected from a population. So an example would be the average credits taken by a sample of students at MiraCosta College. So rather than studying all the students, we select a sample or subset of students. Another example might be the proportion of defective phones in a sample of iPhones selected from phones made by Apple. So if Apple wanted to test their phones, rather than test every single phone, they would take a sample because it's more cost efficient. This leads us to looking at our different sampling techniques. There are non-statistical sampling processes which use convenience, judgment, or other non-chance processes. Whereas you have statistical sampling, where these methods use selection techniques based on chance. Simple random sampling is a very commonly used sampling technique. This is where every sample has the equal chance of being chosen. Now, selection can be with replacement, meaning once we take a participant out, we put a new participant back in, or without replacement, meaning when we take the sample out, we leave them out. Now, the sample can be obtained from a table of random numbers, or you can use a computer program to generate it. Excel can actually do this for you. Another sampling technique is the stratified random sampling. So what we do here is we will divide the population into subgroups called strata based on some common characteristic. So let's say we divide the population men to women, or perhaps income levels such as low income, middle income, and high income, right? Then we will select a simple random sample from each subgroup and then put those subgroups into one. What this does is it evenly pulls the same number from different strata. So an example here in business would be if you think about banks or financial institutions, we don't have the exact same number of large, medium-sized, and small. So to have a more even sampling set, we would split our population into the 3 strata and then do a simple random sample of, let's say, 10 from each. So it makes it a little bit more even to be pulling 10, 10, and 10 financial institutions from the different strata. We also have systematic random sampling. And so here we want to identify a particular sample size, denoted lowercase n. Then we divide by uppercase N, which is the population size. And that will give us our K item. So what we'll do is we'll randomly select item between 1 and K and select every K individual after. So for example, if you have a population of 12 people and you want to take a sample of 4, we take our population size of 12 divided by our sample size of 4, and that tells me I need to pick every third person out of the group. So that's how we see in the figure here, where we randomly select the number between 1 and K in this case being 3. So randomly we chose 2. So the second person, then 3 up is the 5th person, then 3 up is the 8th person, and then 3 up is the 11th person. Then there's cluster sampling. This is where we divide the population into clusters that are representative of the population. And this is typically geographical. So here we would select a simple random sample from clusters. All items in the selected clusters can be used, or items can be chosen from a cluster using another sampling technique. So one way to think about it is if we looked at Oceanside and we could imagine each block of homes or street is considered a cluster. And so we can randomly select a couple of different streets or neighborhoods or blocks, and then those would be what we want to study. And perhaps we want to use simple random sampling, so we're not studying the whole block, maybe we'll study 3 homes on each block. The business example here is a warehouse manager wishes to select a statistical sample of products in the warehouse. There are 10 aisles, and there are bins stacked 3 high and 20 stacks per aisle. So that's a total of 600 bins in the warehouse. Each bin is a cluster. So we would go around, and this is again reflective of a geographic location of a bin. And so we randomly select 5 clusters or bins and sample each item in the 5 bins selected. So here's a summary of the different sampling methods that we looked at. We have non-random sampling, meaning it's non-chance, and then we have random sampling. So every participant has the same chance of being chosen.